Okay, so in this video I'm going to have a look at the area between two curves. And I have the two curves drawn here. One is f of x, that's this one here, that's x squared minus 4. And the other one is g of x, which is this one here, an inverted parabola, and that is 8 minus 2x squared. I'm going to have a look at the area in between, this purple and green area added. Now, I just got to be a little bit careful here. This area here, when I calculate it, when I use the integral to calculate it, will be positive. But any integral you do that involves finding an area underneath the x-axis, you will end up with a negative answer. Now, you can't have a negative area, so you got to make that negative positive. You got to find the absolute value of that area, or the modulus of that area. So we'll have a look at that in a few minutes. Now, from the graph here, we can see that the graphs cut at -2, +2. They intersected -2 and +2 here. But if you weren't given that in a question, if you were just simply asked to find the area between these two curves, the first thing you would have to do is find, you're going to have to integrate, so you're going to have to find the limits of integration. And the limits are going to be between -2 and +2 here. But if you didn't know that, you would have to find out where these two curves intersect. So we're going to assume we don't know that they intersected -2 and +2 here. So what you would do is just let them be equal first of all. So you've got x squared minus 4 equal to 8 minus 2x squared. So you want to solve this for x. You want to find out what x values will make these two functions equal. So let's do that. Bring this minus 2x squared over here, or add 2x squared to both sides. You end up with 3x squared on the left hand side. On the right hand side, bring this minus 4 over, or add a plus 4 to both sides. You get 0 here, and you'll get 12 here. Now divide by 3, so you get x squared is equal to 4. That gives us x is equal to the square root of 4, which is plus or minus the square root of 4, which is 2. So this is where our +2 and our -2 come from. This is where the two functions meet. This is where they're equal. So now I have my limits of integration. So let's integrate each function. Now the first one I'm going to do is I'm going to find the area underneath the gx, the function g of x here. So this is my g of x here. So I've got to integrate it between -2 and +2. So let's do that. So I'm going to integrate g of x. I'm going to integrate g of x, which is 8 minus 2x squared, with respect to x. And I'm going to integrate it between -2 and 2. Between here and here. That will give me this purple area here. So let's do that. So we'll do our square brackets as usual. So integrate 8, you get 8x. Integrate 2x squared, you get 2x cubed over 3. And I'm integrating between -2 and +2. So let's work that out. So I stick 2 into the equation, or to the expression first. So I've got 8 bracket 2. Just put a big bracket there as well to separate it. So I've got 8 times x, or 8 times 2, minus 2 times 2 cubed over 3. Okay, and now I've got to subtract what I get when I substitute in -2. So put -2 in here. So I've got 8 times -2 minus 2 times -2 cubed over 3. Okay, so let's work all of this out. Here I've got 2. Here I end up with 2 cubed, which is 8, 2 8, 16, so that's -16 over 3. Here now I end up with -16, 2 8, 16. Here I'm going to end up with, let's see, a minus cubed is a minus, times a minus, that'll give me plus anyway. 2 cubed is 8, 2 8, 16 over 3. Okay. So let's continue this on then. Let's see, I end up with 16. Well, actually, you know what I'll do? I'll just take away these brackets completely at this stage. So I end up with 16 minus 16 over 3 plus 16. and then minus plus is minus 16 over 3. When I do all of that, then I should end up, let's see, 16 over 3 minus, I should end up with, let's see, 20 minus 16 over 3 minus 16 over 3 plus 16 plus 16. I should end up with 21 and a third. 21 and a third. If my mental arithmetic is correct, that should be right. So that's my first area. So this is my first area here. Okay, that is the area here, the purple area here. Okay, so let's do the second one then. Now, second function was x squared minus 4. That's this one here, x squared minus 4. I'm going to find this green area here. So I should end up with a negative answer. So let's see, do we? X squared minus 4. X squared minus 4. So we want to integrate x squared minus 4 with respect to x, and we want to integrate between minus 2 and 2. So let's do that. So we have x cubed over 3 again, minus 4x, and minus 2 to plus 2 here. So let's work all of that out then. Okay, so we want to substitute 2 in, so we're going to end up with 2 cubed over 3 minus 4 times 2 minus, so let's put the minus 2 in now, so it's minus 2, and we want to cube that over 3 minus 4 times minus 2. Okay, so let's work this out. Let's see, here we end up with 2 cubed, which is 8 over 3, minus 2 fours, 8, minus, now minus 2 cubed is minus 8 over 3, and here we end up with plus 2 fours, 8. Okay, so let's continue on again. I'll just take away the bracket, so we end up with 8 over 3 minus 8 minus minus plus 8 over 3, and then we end up with minus 8 here. Okay, so what does all that give us? Let me see, we should end up with, let's see what we've got, 8 over 3 minus 8 plus 8 over 3 minus 8. That will actually give us a negative number. That will give us minus 10 and 2/3. Okay, and that is the area of our, that's our green area here, which is underneath the x-axis. We expected a negative answer. We got a negative answer here. So it's, that's okay. So that's our green area. So we've got to add these two together now in order to find the total area. So we're going to add these two together. Now remember, you can't have a negative area here, so I've got to change this to a positive number. So really what I'm doing here, if you like, is what I could have done from the start here, if you like, is, you know, just got the modulus of the integral here. So I got the modulus the whole way down along. So the modulus of this here is just simply going to be equal to 10 and 2/3. That's the actual area, 10 and 2/3 units squared. So let's add these two anyway to give us our final area. So we've got 21 and a third. So let's say we'll do this in blue. 21 and a third plus 10 and 2/3. That will give us 21, 31, 32 units squared. I haven't said what the units are, but in this case we'll just say unit squared, general unit squared. So this is our answer. This is the total area between these two curves. Total area between these two curves between minus 2 and 2. Okay, so that's just one example. Now, if you have another two curves, for example, I'm not actually going to do this out, but let's say you have your y-axis and x-axis, and let's say you have, let's say a curve that looks like this, and let's say another curve that looks like this, and you want to find the area in between. Okay, so you want to find this area here. Well, what you would do something similar again. You would see where the two curves intersect. So the two curves in this case intersect here and here. So that would give you your limits of integration. So let the two functions be equal, solve for x, find the limits of integration. Now, in this particular case, what you would need to do is take this curve here. Let's call it again f of x. And we'll call the green one, let's say, g of x. Again, we'll call this one g of x. What you would do is integrate f of x. So you would integrate the function f of x, first of all, between your two limits. Let's say we'll call them a and b here. So this is x is equal to a, x is equal to b here. Okay. So you would integrate between a and b f of x with respect to x. Okay. That will give you this area down here that I'm going to do in white here. That will give you the area underneath the curve here in white. So then you would integrate g of x. So you would then take g of x and integrate that. So you would take g of x and integrate that with respect to x between a and b. Now that's going to give you, I won't actually color this in because it's going to get a little bit messy, but it will basically give you all of this area underneath here. The white area plus the purple area. So what you would then do is subtract these two. You would take all of this area underneath the green, g of x, subtract the white area here, which is the integral of f of x, and that will give you the purple area here. So really what you would do is you would take the integral of f of x between a and b with respect to x. That gives you all of this area underneath here. No, sorry, actually it's, let me just start that again. Okay, so what you would do is you would take the integral of g of x, not f of x. You would take g of x first between a and b, because g of x is here, so that you would end up with the area underneath g of x here with respect to x, and then you would subtract the integral from a to b of f of x with respect to x, which is this area here. So you would subtract the white area, and that will give you the purple area here. Okay, so I won't actually do one of those, but that's generally what you would do.